Hej och välkomna till DreamArena Orange. Det är dags för sista programmet på eventet. Det är DreamHack behind the scenes som presenteras av DreamHack Network. Varsågoda.
Tack så mycket. Karl Andersson heter jag, nickar Ice, och jag är TA tillsammans med Robin över Network. Den här presentationen kommer ges i två delar. Den första delen ges av mig, och då är det hur vi bygger nätverket på DreamHack. Den andra delen kommer ges av Robin, och han kommer tala om IPv6 och nästa generations nätverk som vi kör här på DreamHack. Det är lite spännande med tanke på att Sveriges nationaldag inträffade samtidigt som världens IPv6-dag. Och då slog man på, man slog på IPv6 på många stora sajter, och Robin kommer berätta mer om det här senare. Jag är Karl Andersson. Jag ska köra den här föreläsningen på engelska, kommer jag precis på. So let's switch to English for all. Is there anyone who only understands English here? Yes, I will do it for you and for the people on the stream. I work at NetAdmin Systems, which is a company in Linköping with about 40 people, and we do provisioning of big networks, and we have a system here in place as well. For me, my background is I'm studied at Linköping University, and I love technology. The team, this picture was taken last summer, and I really love this picture because it's in front of the new POP that we built, or the tech hub that you can visit down in Telia in D Hall. And we are about 30 persons who share a common interest in building networks and technology. We have a lot of different kind of people, or people that work with a lot of different things. So we have network technicians working with routers, switches. We have electricians. We have people who build stuff. So it's a really wide area of people. The group or the team, the network team, is divided into 4 parts. The first part is the access team, and they are out on configuring the actual table switches that you see if you sit at a table. They configure these ones. They put the cabling in from the table, and they manage that. And they also manage Wi-Fi, or a big part of the Wi-Fi, putting that up. We have the core team, which manages the bigger routers, the white routers, in our POP or tech hub. And they also manage the distribution network, which I will talk more about later. Then we have the services group, and then they manage DNS, DHCP, all those kind of things that are necessary to run a network of this size for up to 20,000 people or even more. That comes in and does this visit, uses the network for 72 hours, and then tear it down. So we need DNS, DHCP, a lot of support functions that we have internally. Example is configuring switches and a lot of different things. Then we have logistics, which is a rather new group, but it starts to sink in, and it's working really well. There are 2 people in the logistics group, and they manage we have about 40 pallets of stuff, different stuff, cables, hammers, and everything you can think about we have. And they manage this, and they manage transporting of this. So this is a offloading, really big offloading for me and Robin, who are the team responsible, or team leaders. We also have about 10 people, so it's 10 people from partners that are on site or have been on site during the building, and they are from Telia, which is have around-the-clock people or technicians that can help us, assist us if we have problems on mostly on the internet side, or if anything happens that we need assistance with. So they have a big presence. Then we have Procera, which supports us or sponsors us with technology to prioritize gaming traffic and collect statistics. They have had between 2 and 3 people here. That's really helpful using their products. This year we did not have anyone from Fortinet, but they are here sometimes as well to assist us with firewalls that protect our servers. Then we have some NetAdmin people that's been here and running the NetAdmin system for monitoring the network and to provide a kind of new special thing that I'll talk about later. So building it, it's a bit like building a city network in really, really short time. We build it on site here at Elmia for 5 days. And before that, we prepare ourselves for maybe 2 months. We actually arrived here in Jönköping, most of us from the network team, on Friday 1 week ago. A little bit more than 1 week ago, when we first had we go out, eat some food, and then we discuss and start planning and start configuring the things. But during these 2 months, we have regular meetings, or weekly meetings, where we do the planning of building this network. Then, when we actually do the building, we build it for 5 days. And we work, on an average, we work about 16 hours per day. Some people work a little bit more, some a little bit less, but on average 16-hour days. And that totals of about 3,000 hours project that we run when we build the network. And this is just on-site time. And so this is quite a huge investment of time to make the network work. We operate it for 72 hours during the event, and then we tear it all down in 1 day. And that day we are all very sad because we have to go home and wait another half year until we can come here again. Some quick internet history. This is how DreamHack's internet speeds have evolved during the years. Last year we had 120 gigabits per second, which is quite a milestone. This year we have 40 gigabits of internet. Next year, or next event, we will see. New for this event, we have a Twitter account where some of you have been following us, maybe. If not, please follow us. We do kind of regular updates on it when we build the network, things we do, and funny pictures or interesting pictures. And we also have the one that is up here. We have an interesting thing. We have one user in our network that runs Windows 98, apparently. When this was discovered by when the clients request the HTTP or wants to have an IP address, they say which version of the operating system they run. So someone is running Windows 98. Maybe a virtual machine, but probably not. So that's so sad for him. This is the network for this year. And down here we have the POP, or Tele Hub. And in that place we have 2 routers, which are the big circles. And what they do is basically the same functionality as a router at home. It takes the internet traffic and it changes the ports on where should this traffic go. So it routes it onto different places. It does not do NAT or network address translations. Everyone gets a public IP address so that they can use the full internet experience. From this place, we have 2 links to every stack. And this is the part of the distribution network. And on the distribution network, we then connect the table switches. So for each of these, for this one, there is connected table switches, 3 of them for each table. And this is quite a nice design from the point of view that the routers here are redundant. So if one of them get a power shortage or if it breaks down, then we still have full capacity, or we have enough capacity to manage these without anything affecting the end user. So this is a quite nice design. And as you can see, this is the whole Elmia. It's quite huge. Right now we are up here, actually here, and we're connected through cabling that goes down here in the floor and connects to our switch, which is in a cabinet somewhere, I think up here or over there. So we actually take our own equipment in, or our own network in, and we use the cabling from Elmia, but we replace it with to get our network here. And this is done for this area up here and part of the B. Out here in the big halls, we do all our own cabling. So there the access team do most of that cabling, and they put in all the trunks and everything. Any questions on the network design from this material? No. We will have a chance to ask more questions with microphones later at the end of the presentation. In the POP, you can see this display, and that shows the current status of the network and the current speed of our internet connection. Up here, you can see a rotating globe, which shows where in the world DreamHack is connecting to. And the brighter the white, the more connections. There is a small dot in Hawaii and some in Africa, but most are concentrated to Europe like this and to USA. And if you go into dashboard, DreamHack.se, you can have a look at this yourself and share it with your friends. This is the current speed, and then we have the max speed that has been achieved, how many hard drives, how many terabytes of data have been moved in and moved out during the event, and how many unique clients we see in the network, and the world record last time. Then we have a flowing how fast is it going right now and the history of the speed, and what games or distribution of what kind of game, and you can see that Diablo 3 is a big winner in that respect. The pulp has the 3 racks, the black ones you can see. They have a redundant power supply of 63 amps, which is the same as one table has, or actually 2 tables, have one 63 cable, which is about this thick cable, and we use 2 of them for our network devices that are in the pulp. Please come visit us. There are usually some people there. Telia have people around the clock. Ask any questions you have, and they are sure to have the answer. Picture of the picture on the left is from the pop, and the picture on the right is from one of our cabling out on the table. So here we have the trunks from TP or twisted pair that goes into the rack, and then we have patch cables that connects it to a switch that is down here. As for routing, we use ISIs internally, both for the IPv4 and IPv6. We also use BGP internally to carry the actual table switches. If you have technical questions about this and would like me to tell you more about it, please come visit me after the lecture, and I can have a private BGP and routing session with you. We use BGP towards Telia. This was actually new from last year, and we have our own AS, which allows us to do routing. We only have one internet provider, but if we would like to move to having multiple, we can do that now, and we can take it in from a lot of difference. The BGP, what that allows for us, or running BGP with Telia, that allows us more to control where we want to traffic, which of the links we want to send the traffic on. Some quick BGP statistics showing that most of the traffic is going to Telia, or actually most of the traffic is level 3, but besides that, most of it is going to Telia, Sweden. So this is actually how the traffic on the internet is routed, is between BGP. So for all of these numbers are autonomous companies, basically, you can say. So if Telia actually has 2, one for Sweden and one for global here, and this is how much that goes globally in Telia's network, and this is how much goes into Sweden Telia network. The equipment, the routers are sponsored from Cisco, and they are this one, which is on our ASR 9K. We used it at DreamHack first time last event, and we are very happy with this platform. And previously used the 7600 platform, and it did a really good job, but this one is a much newer platform. It's designed to go from now into 30 years in the future, so it's really redundantly built, and it's really stable. Besides the Cisco, which the Cisco makes up the bulk of the network, the Cisco equipment, some of that is owned by DreamHack, and some is sponsored by Cisco. Other than that, we have some different network elements from Procera, Fortinet, and Dell. Dell sponsors us with servers, which we run all of the support functionality that we need. And then Fortinet sponsors us with firewalls to protect these servers from attacks. And we have Procera to prioritize gaming traffic. Basically, IPv6 graph, IPv4 graph, and IPv6 graph. The IPv6 graph is quite, it changes a lot. We have about 1 gigabit per second of IPv6, and IPv4 is about between 10 and 15 gigabits, so it's quite small still, the IPv6 traffic. Why is this, we ask ourselves, and then we used some statistics to find it out, and we can see that YouTube is actually changing a lot. The blue one is the incoming IPv6, and the red is the incoming IPv4. And what YouTube does, it sometimes sends it over IPv4 and sometimes over IPv6. So this this changes a lot of how much IPv6 traffic, because IPv6 traffic is really making up almost half of the traffic is coming from YouTube over IPv6 for us. The distribution of internet usage is that if you go for 10% of the hosts in our network, they make up for 64% of the internet or the traffic, the internet traffic. If you go up to 40%, then it's almost all of the traffic. So you can see it goes upwards. So it's actually quite a small, or if you go for half of the traffic, it's made up by only 4%. So 4% of all the people uses half of the internet capacity. And some distribution of which uses, and Tech Crew does a lot of testing with web browsing. We download from test servers to make sure that everything is working correct. Gaming, the top games, League of Legends, Diablo 3, and so on. Use a lot of cables. We bring in these 40 ballots, we bring in 25 kilometers of TP and 5 kilometers of fiber that we pull out in the whole network. So it's quite a lot of cabling. Some troubles that we have during building and during event. During event, it's mostly broken table switches and broken TB cables that causes most of the problems. From this year, I've heard that since we switched to Cisco 2950s, we have a lot of fewer problems because the previous version that we used, the switches were quite old. They were end of life. So now we've got a fresh batch of switches that's working much better. The spanning tree PVST MST problem is a bit complicated, but during building the networks, we usually get some problems that we fix over time, and then when the event starts, or actually the day before the event starts at about Friday, network, we have a stable network, but during the building of it is quite unstable because we build it it's looped from the beginning, so traffic can flow around in a circle from two devices. And this is prevented by a spanning tree that blocks some of the links, and then you don't get a traffic loop, you only have a loop from the cables. This event, we had some problems with VPLS and spanning tree because we had a few switches, maybe 5 we can say, that were connected to the routers. And on L2, on layer 2, they send these spanning tree messages saying they try to decide how should we build a network that is not looped so that we get a stable network. And because the design that we used, or how we implemented the design, how we configured it, we got the problem that the network was quite big. It was a lot of switches, and everyone was talking at the same time. So the switches didn't have enough CPU capacity to, when we run PVST, which is, let's say, 300 VLANs or even more, that they need to calculate how should I build a network that's loop-free. So they didn't have enough time to do it before the next time they needed to do it again. So we used this to fix this problem. We changed to MST, which groups the VLANs together. So instead of calculating it 400 times, you calculate it 3 times in groups. And then you say, OK, for these 3 types of VLANs, we should build a network like this, and then it will be stable. If you have any further questions on that, so please come visit me after the lecture. I can go into all the gritty technical details. Configuration is done by a script that we developed internally. And this is our nice overview of it. So we look at these green boxes when they flip around when all the switches are configured. So we have 400 switches, and they all need to be configured. We have a new record for that this year. I told you about this last year, or last event. And this year we did it 345 switches in 4 minutes and 47 seconds. Last time it was 15 minutes. So we'll see if we'll break that record again the next event. And we can erase them in 28 seconds. We test it all, and there we use Where Am I, which is an internally developed test tool or test web page. We're monitoring using Seeing It, or our support that you can visit in the D Hall. Use this view to see which switches goes down. Are there any problems in the network? Is there a power outage? If they see a red thing, and you can visit them in the D Hall and talk to them and see this view. And there's a red one, they will send some electrician there to do troubleshooting. If you visit dreamhack.netadmin.se, you will see this page. And on that one, you can see your statistics. how much bandwidth am I using on my table switch, and you can bring that home. I think maybe you can even share it on Facebook. And we also have an achievement system implemented here, where you can get achievements from the network by doing certain things. So visit dreamhack.netadmin.se, and you can see that. Our partners, that without them, we couldn't build this wonderful network, and they provide a lot of interesting workshops for us and educating us. We love to learn about new technology, and these partners make that possible for us. When we don't work at DreamHack, these 30 people work at a lot of different companies. I will not read them all, but for the YouTube, if you pause here, you can see where we work, and maybe contact some of these cool people, cool companies. They do amazing things. And DreamHack Crew is always recruiting, and Network is recruiting as well. If you think you can contribute and do something special for DreamHack Crew or DreamHack Network, come visit me, or go to crew.dreamhack.se to visit there. And now I will hand over to Robin. Thank you. I will return after Robin is finished to take any questions.
Hi. I'm going to talk about IPv6 and the IPv6 implementation here in the DreamHack networks. My name is Robin Larsson. I normally work for a company which name is Base Farm, where I work with operating internet sites. Here at DreamHack, I'm a member of the services team in the network group, which means I'm a member of the team handling all the helping services for the network, for example, DNS, DHCP, SMTP, and things like that. Why should we switch to IPv6 when we have IPv4? IPv4 is the protocol used on the internet to carry all the traffic, but the address space is too small. IPv4 is based on a 32-bit address. And like you can see, it allows the digits here, this amount of total IP addresses. Every computer that is connected to the internet has an IP address and needs to have one. So to be able to grow the internet, IPv6 was developed. And the IPv6 protocol, we instead have a base of 128 bits in every address. So, for example, this is an example of IPv4 address. This is an example of IPv6 address. And if you're looking at this number here, you can see how enormously huge amount of IPv6 addresses you can get from the address space compared to the address space on IPv4. So that's the main reason why we need to switch to IPv6 on the internet. There's more reasons. In IPv4, we use something that's called NAT, Network Address Translation. So for example, NAT is used to handle the problem with IPv4 shortage. So for example, many times in companies you have a huge amount of IPv4 addresses inside of your company, but when you go and surf outside on the internet to your the web, your IPv4 address is translated to only a few public IPv4 addresses, making the company not have to use the big amount of public IPv4 addresses. In IPv6, the goal was to remove NAT, or Network Address Translation, in the beginning. But now it has come to that there has been some Network Address Translation specifications for IPv6 as well. So in the future, we will have to see what's happening with NAT and IPv6. But in the beginning, it was designed to not use NAT at all. IPv6 has also built in a specification for multicast. Multicast is a way of, in one transmission, talks to a lot of computers. It is very commonly used for streaming videos, because then you don't want one client send out the stream to all the people watching the stream. And with multicast, you can in one operation send out a package to many clients. This is commonly used in IPv4, but in IPv6, it is built in the specification. How to get set IPv4 address. I will discuss this because we need to understand the difference between setting an IPv4 address and setting an IPv6 address. In IPv4, there's two commonly used ways. You manually set your IPv4 address. This is commonly used on servers and routers and things that you know that this device needs to have this address in this network and it has this gateway and so on and so on. For clients, the most common way of setting your IPv4 address is through DHCP. When it works like this, when I connect my computer to the network, I send out a request asking, I would like to have an IPv4 address. And then the DHCP server answers, here is your IPv4 address, this is your DNS server, and this is your gateway. And then the DHCP server knows about all the IPv4 addresses in the network. So it knows, like, this client has this IPv4 address, it will have it for this amount of time. That's how it's working in IPv4. In IPv6, we have three commonly used ways. We have the manual way, where you set your IPv6 address manually. So you tell the computer or device that this has this IPv6 address, it has this subnet, this gateway, and this DNS server. And we also have the IPv6, DHCP version 6. It operates in quite a different way than the DHCP in IPv4. In IPv6, you use, in DHCP v6, the client asks the DHCP version 6 server for an address, but it asks the server in a different way. It asks the server with, it uses a link local address. I will get back to this later. We also have Slack. Slack is the new way of setting the IPv6 client address. It works in the way that the client asks the router, in what network am I? And then the closest router, or the router on your network, will tell you that the client that you're on this network. And then the client itself calculates its own IPv6 address. So this is the 4 ways of setting an IPv6 address. I will go through Slack a bit, in a bit deeper. So, but first, we need to, I think I moved this the wrong way. Okay, there was a bit slides that has been removed, so I will continue with this instead. In how Slack works. Slack works with using ERA. When you connect your computer to the network, every computer gets a link local address. The link local address is an IPv6 address that is used to talk on the local network. So, and also the router on the local network has a link local address. And the Slack works like this, that when you connect your computer, you get the link local address. Then you use the link local address to talk on a multicast group on that link. Then all the routers on that link or that network listens on this multicast address and will give you back a prefix. The client takes this prefix and calculates its own IPv6 address dependent using its own MAC address. This is a bit technical, so if you are more interested in this, you can come and talk to me later. And this is DreamHack's IPv6 implementation. At DreamHack, we run IPv6 for all the clients, and it works using Slack. So when you connect your computer, you calculate your own IPv6 address. There's a limitation with Slack that you can't set your DNS server. The DNS server is used to translate domain names to IPv4 and IPv6 address. So to resolve this issue, we use DHCP version 6 to send out the DNS option. So you will get the DNS. We have a /64 on every VLAN. To get this to work, we also have enabled IPv6 DNS servers that will answer all the DNS questions. In DNS IPv4, you have R records, but for IPv6, you have quad R records. To do this, we use Debian. We also use Bind as a DNS server, and we use IPv6 tables for firewalling IPv6. What's the problem with IPv6? For example, what's the problem with IPv6 here at DreamHack, or for example, during the IPv6 day? For example, say that you get a IPv6 address to your local computer. You also have an IPv4, so you are dual stack. You have IPv4 and IPv6 address. You ask the DNS server for the IP of www.youtube.com. Our DNS servers will give you the quad R record. The quad R record is the record for the IPv6 IP address. Then your client will try to connect with the IPv6 address, which the AAA record points to. If the IPv6 is not configured correctly all the way, the request will time out. And what I meant with that is, for example, your ISP could have a working IPv6 network, but the next hop from the ISP maybe will not. So, for example, here are the clients, here are the DNS servers, and here are your network. At DreamHack, all this is IPv6 compatible, or it works with IPv6. Here you have an ISP that has broken IPv6 routes or usability. Here you have YouTube. YouTube has a working IPv6 implementation, and YouTube's ISP has also a working IPv6 implementation. So when you send out a DNS question to give you www.youtube.com, you will get the answer in the quad R record that www.youtube.com is at this IPv6 address. The request will be routed inside your ISP network, which at DreamHack works fine. The request will be sent out from, example, Telia to a different ISP somewhere on the internet. This ISP may be not having IPv6 implementation correctly, so your request will then time out, and you will then fall back to IPv4 to connect to youtube.com. So that's the problem, and that was also what happened during the IPv6 day. That was all I had about IPv6. If there is any questions regarding IPv6 or regarding something else that the DreamHack network team is doing?
Yes, I think there should be some microphones in the... Where are the microphones? Okay. If you have questions, please raise your hand, and I will try to hear what you say. No questions?
If there are more technical questions, you can come to me and Ice, and we will gladly discuss them with you.
Definitely. So come join us afterwards, and we have a question. Just 1 second. If there are any people that are interested in a tour of the network, me and someone else from the network team will do that afterwards. So if you're interested in a tour of the network, we'll walk down into the D hall and B and C just around the area and show you some of the physical things that we have out in the network. If you want to see that, please stay here after the talk, and we will do that. I know that I will walk around, but I have not found, maybe, yeah, Marty will do it here. He will join me. So we are 2 people, and this guy. So I think there will be a few from us that you can ask more questions for. So, guy with the... Yes, the question was, what is up with the Wi-Fi? What's up with the Wi-Fi is that there are too many clients, and new for last event and this event, that there are too many cell phones that uses the wireless. So we have close to 100 access points, but sadly that is not enough, because the tight space and how the 802.11b works and G works is that there is this much space in the radio spectrum, and there are really only 3 channels that you can use. But because it's such a closed space with so many clients, we tune down the AP's amount of power that they send out, but we cannot, unfortunately, make it work in some of the areas. In some of the areas it works better, in some it works worse. So if you need to get wireless access, try to visit a place where fewer people are, and it will work better. For example, I know where the crew have our area, it works perfectly. Of course it does. Any more questions? Okay, so if you have any questions or want to join the tour, please stay behind, and we will do that.
Thank you.
Thank you very much for...